Okay, in this video we're going to solve radical equations. So the variable is going to be buried inside of a square root or a cube root, and so we're going to need to undo the square root so that we can get to that variable x or y or whatever they're asking us to solve for. And then of course after we solve, we're then going to have to check, because sometimes you'll have an extra solution that's not valid and it'll be not part of the solution. So let's go ahead and take a look at it, kind of building on some of our previous lessons where we have to undo the square root. So of course pretty good at that now. Just basically raise it to the exponential value of the index. So since square root has an index of 2, we're going to square both sides, and that's just going to cancel the square root on the left, and of course 5 squared is going to equal 25. And then we're just going to need to add 18 to both sides, and that gives us 43 when we add 25 to 18. And then we're going to have to divide by 7 so that we can get x all by itself, and it looks like we're going to have to test x equals 43 over 7, and we'll do that over here. So we have 7 times 43 over 7, and subtract 18, take the square root of that, and we will check to see if that's equal to 5 in fact. So of course notice that the 7's cancel out and you just have 43 minus 18, which equals 25. And the square root of 25 in fact does equal positive 5, so we'll go ahead and record our solution right here, 43 over 7. Okay, well, let's do another one. It's a little bit different. Hopefully we won't end up with a fraction like that. Notice that right now that plus 1 is on the left side by the square root. So our job will be a whole lot easier if we go ahead and subtract 1. So if we subtract 1 from 3, we get 2. And then the only thing on the left side is the square root of 3x minus 8. And we'll just simply get rid of that square root by squaring. And we get 4 on the right and 3x minus 8. And we add 8 to both sides. Add 8, and we get 12 and 3x, so divide both sides by 3, and x equals 4 is our solution we need to test real quick. So plugging in x equals 4, we get the square root of 3 times 4, which is 12, 12 minus 8, whoops, plus 1 equals 3. So we have 4, square root of 4, which is 2, and 2 plus 1 equals our 3. So that one was a little bit easier because we didn't have the fraction to deal with. Alright, let's look at number 3. I'll erase this. Alright, so here we have kind of similar to the last problem. We have this minus 24, but notice that here we have the quantity 8 times the cube root of x. So we're going to actually get rid of that before we take both sides to the third power. So adding 24 would rearrange this equation to be equal to 24. When we add 24, it becomes positive. And then we're going to divide both sides by 8 first. That's the cube root of x. And let me scoot this over just a little bit. Equal to 24. And of course we're going to divide both sides by 8. And we're going to get 3. And now we have over here is the cube root of x. So we'll just raise it up to the third power on both sides. and we'll get 27 is equal to x. So let's go ahead and test that solution out. 8 times the cube root of 27 minus 24, and that hopefully will equal 0. Of course, the cube root of 27 right here is 3, and 3 times 8 minus 24, you get 24, subtract 24, and that does in fact equal 0. So x equals 27 is our solution on this one. Alright, let's take a look at problem number 4, and then we'll make this the last one here. Not a whole lot different on this one. We still need to get everything by itself, so I'm going to go ahead and subtract 7 on both sides, and you get 4 square root of x equals a negative 4, and we're going to divide both sides by 4, and we get the square root of x equal to a negative 1, and we'll go ahead and square that, and when we square that we get x equals 1. And let's go ahead and test our solution real quick. So let's test it in green. We have 7 plus 4 square root of 1 equals 3. 7 plus 4 times 1 equals 3. Looks like we're not going to have a good solution here. 7 plus 4 is 11, and 11 certainly does not equal 3. So we have come to a no solution here. Okay, so just follow your steps when you're attacking your homework in section 9.5, and just remember that you're going to try to get, step 1 is to get the radical all by itself, and then you'll square or cube both sides to get rid of the radical, and then we'll just solve for x, and then of course don't forget that last step as you saw on problem number 4, where you need to check for solutions that aren't valid or extraneous solutions. And good luck with the homework.